Do not forget, you can support the channel with a like, and you can also subscribe to be aware of the latest published videos. Thank you. We hope that here you can find the latest news, ideas, and discoveries from the scientific world.
ChineDue, due to its potential for in-situ resource utilization by future lunar exploration missions and other space missions, lunar surface water has attracted significant attention. Now, a research group led by Professor Sen Hu from the Institute of Geology and Geophysics of the Chinese Academy of Sciences has found that impact glass beads in Chang'e-5 lunar soils contain some water. Detailed studies show that these glass beads are likely a new water reservoir on the Moon, recording the dynamic ingress and egress of solar wind-derived water and acting as a buffer for the lunar surface water cycle. This work will be published today in the journal Nature Geoscience. Scientists discover water reservoir on the Moon. Many lunar missions have confirmed the presence of structural water or water ice on the Moon. There is little doubt that most of the Moon's surface harbors water, though the amount is much less than on Earth. Surface water on the Moon displays diurnal cycles and loss to space, indicating that there should be a hydrated layer or reservoir at depth in lunar soils to sustain the retention, release, and replenishment of water on the surface of the Moon. However, previous studies of water inventory of fine mineral grains in lunar soils, impact-produced agglutinates, volcanic rocks, and pyroclastic glass beads have been unable to explain the retention, release, and replenishment of water on the surface of the Moon. Therefore, there must be a yet unidentified water reservoir in lunar soils that has the capacity to buffer the lunar surface water cycle. Doctoral student Hugh Cunny, under the guidance of Professor Sen Hu, proposed that impact glass beads, a ubiquitous component in lunar soils with an amorphous nature, were a potential candidate for investigation of the unidentified hydrated layer or reservoir in lunar soils. She systematically characterized the petrography, major element composition, water abundance, and hydrogen isotope composition of the impact glass beads returned by the CE5 mission, aiming to identify and characterize the missing water reservoir on the Moon's surface. The CE5 impact glass beads have homogeneous chemical compositions and smooth exposed surfaces. They are characterized by water abundance up to about 2000 mg, G1, with extreme deuterium-depleted characteristics. The negative correlation between water abundance and hydrogen isotope composition reflects the fact that water in the CE5 impact glass beads comes from solar winds. The researchers also analyzed water abundance along 6 transects in 5 glass beads, which showed the hydration profiles of solar wind-derived water. Some glass beads were overlapped by a later degassing event. The impact glass beads acted as a sponge for buffering the lunar surface water cycle. The researchers estimate that the amount of water contributed by impact glass beads to lunar soils varies from 3.0 times 1011 kilograms to 2.7 times 1014 kilograms. These findings indicate that the impact glasses on the surface of the Moon and other airless bodies in the solar system are capable of storing solar wind-derived water and releasing it into space, said Professor Hu.